So can you give a brief like overview about yourself, like who you are, how much Leetcode have you done, like what you're applying for, things like that?
Yeah, my name is Tin Lee. I'm studying at Portland State University as a senior, and I will be graduating soon. Um, I'm here for practicing for mock interview for faang level, and I've done around 3,000 lead code problems.
Okay, cool. All right. I think yeah, you've done the most I've seen so far. Okay, so for the first one, let me write it up here. Okay, so you have a grid full of numbers. So let me just give you maybe we'll do a smaller grid. So we have like 1, 2, 3, or
Mhm.
maybe like it's 10, 20, 30. Then we have like 8, 1, 2, something. Just line this up. Okay, and then we have like so we have 10. Let's say we have 10, 23 here. We have 10, 10, 10 maybe. Okay. So what I want to know for this one is you can start anywhere in the grid and you can make one turn at most. Let's actually make this one. So you can start anywhere in the grid, you can make one turn at most, and you're going to multiply all the numbers that you like traverse. And what I want to know is what's the maximum amount of trailing zeros you can have in a path that you take. Um, does that make sense? So I'm going to write that down. So you start anywhere, you can make one turn at most, and multiply path. What's max trailing zeros?
Mhm.
Your path. And yeah, if you have any questions, happy to answer and so on.
So I am given a grid of n times m,
Mhm.
and so I can start anywhere. So basically, if you're saying start anywhere and can one turn at most and multiply any path, what's the max trailing zero? So basically, if I have 1, 0, 0, it would be 2 trailing 0, correct?
Yes. Yeah, so here the answer would be 3 trailing
3.
zeros.
Is that
Because you can go like here, and then go up. That's like one way. Or you can start here and then go down, and then you
mhm,
turn whatever left. So you have one turn. So you basically
okay?
go straight, you have one turn, you keep going as much as you want.
Okay. So I think in this problem, we can do we can start up like backtracking from each position. For example, if I start at 1 right here,
Mhm.
um, I can decide to go upward, downward, left, or right.
Mhm.
And then when I go, for example, when I go to number 2, I can decide to continue going to the grid to the right if I
Uh-huh.
choose or I can choose to like in the recursion, I can have another variable of turn,
Uh-huh.
so I can go upward and then just continue upward to the end of the grid because we want to maximize the trailing 0, so maximizing of going downward or to the rightmost of the end of the grid is the solution that we want to find.
Okay.
Let me think about
So if you did that, like if you did some backtracking, what would be the time complexity?
um, time complexity with this is going to be um, so for example, if we do the worst case, we can do this, go here and then go downward.
Mm-hmm.
It would be n each time, and it would be 2n at most. Um, and there are n square position,
Mm-hmm.
so it would be n cube.
Yeah. So can we do something better instead of backtracking? Like, can we have a
Yes.
better solution?
Yes. So another one we can do is have a kind of prefix, postfix of how many trailing zeros. For example, if I start from 10 and I want to know this, how many trailing zero I can calculate it on this.
Mhm.
And to avoid overflow, we can keep track of the minimum. So we can factor out 2 and 5 to the prime factorization first.
Mhm.
And then the number of trailing zero is the minimum of 2 and 5 on that whole path.
Okay. So you're saying you would do some kind of like prefix count of 2s and 5s and then get them in or something?
Yes. So can I know the constraint on the number and n and m?
Yeah, so we'll just say that your solution will work to where if you add up 2s and 5s, it's not going to overflow.
Okay.
So I'm not going to give you an exact number, but you can assume that if you add up 2s and 5s in a path, it will never overflow.
So I don't need to do 2 and 5 in this case. Is that correct?
Um,
Because I can just multiply the
no,
whole
no, no, no.
thing.
So products will overflow,
Oh, okay,
but
okay.
count of 2s and 5s will not.
Okay, okay, got it.
Yeah.
Yes. So let me think about this a bit. Yes. So we do backtrack. I'm thinking about. So we still do backtrack, but no, it's not really backtracking in this case. We can do. We can choose the point. Okay, so I can have. I have a better solution of n times m only,
Okay.
involving the prefix stuff. So I can choose like this point right here. So continue to the previous thought process. So I will look to the right and to the like down for
Okay.
yeah. I can choose to up right as one option, up left as one option, down left and down right as the other two options. So I have 4 options to look at this, and I would just take the product of that whole how do you call it? That 2 line.
I see. So you said upright, down right. So
Mhm.
can't you also do like up down and these two? Is that not valid?
Up down, yeah, yeah. That counts as well.
Okay, okay. Okay, so you're basically saying like so you can
So I
go
can have like a whole line
uh-huh.
as one option, and the other
Oh, I
is
see.
the 4 option that I talked before.
Okay, so it's like what is it, like 6 or something, I guess?
Yeah, that's 6.
Okay. And so for every point and how fast can you get that for every point?
It's all of 1
Okay. So then you would basically have a what time complexity?
of n times m.
Yeah. Okay, that makes sense. Okay. And then you're going to store like some prefix of like 2s and 5s or something to get these things?
Yes, that's correct.
Okay. Yeah, I think that that makes sense to me. If you want to code it, you can. If you want to talk about anything else, you can. Totally fine.
Okay. So I can start coding. I will name the function solve.
Oh, one quick question. So what would be the space for this?
The space is just n times m to store the whole grid,
Okay.
and I will have
But
just
you're doing like a prefix, right? So are you
yeah.
doing so
So
what are
just
you prefixing?
prefixing is the number of 2 and 5 on the thing.
Okay. And you will have a prefix like grid that because you need like columns and rows.
Yes, I do. So that's gonna be 4.
Okay.
So 2n plus 2m.
Okay.
So n,
sure.
n plus m. Yeah.
Okay. Sounds good.
Can I start coding
Yeah.
now? Okay. Um, so what do you want me to return as the
So just like an int. I think int is fine.
okay. So I will return an int. So I will just see out, just print it out.
Mm-hmm. It doesn't matter too much because we're not going to run it. So like we're just going to look at your solve and see if it makes sense.
Okay. So I think if the grid, first of all, if the grid is empty, I think if the grid is empty, we're just going to return. Oh, what do you want me to return?
Yeah, we
Is
can do
that
0. I think 0 is
0?
fine.
Okay. So what I'm going to do is create 4 prefix. Let me think about how to do this.
Sure.
So we'll create info as to represent number 2 and 5.
And if you do using on a function, does it use is using related to a function or just global?
Oh, it's just like when I do pair. Instead of type pair initial, I can do just info.
Oh, I see. Okay, got it.
It's just
Sounds good.
So I can do create 4 vector of prefix. So I'm going to be prefix room. Let me think. Prefix. No, actually, I only need to create 2 row and column.
Mm-hmm.
Yeah, I only need to create 2.
Oh, did you drop? Yeah. Hey.
Hey, I'm sorry.
Do I need to send you another? Oh,
Yeah.
it's in the chat still, or else send it again.
Control W and I just get used to the Vim and like I pressed it.
Okay,
So,
that's fine. Okay, we're back.
oh, sorry about that.
Sure.
Okay, so I will create a prefix row and prefix column. So I
Okay.
will have a factorize function as I will use a lambda. So we'll return a info, which is the number of 2 and 5 in a number.
Okay, makes
So
sense.
while x is mod 2 is equal to 0, yeah, so I will return it like this. And so we have another grid. So what I think I do is instead of, I would have another grid called info grid, which I will have a just basically a vector A, but store the number of 2 and 5.
Okay.
Okay. What's the error right here? Oh, it doesn't show the error.
I don't see an error.
I see a little red right here.
Oh, I see.
Can I run to see, or I could just come back later?
I think just leave it. It's fine. I don't
Okay.
see it, so I think it's fine. Okay, so basically your info grid is like the 2s and 5s for every cell, right?
Yes.
Okay, makes sense.
So now we'll store a I bring these two back down here. Instead of int, will we do info instead? Okay, so for pre-row of I would say pre-row of I, J is going to be pre-row of I, J plus. I will have another function called merge,
Okay.
which I will combine the number of 2 and 5 onto info.
Okay.
Let me think. Merge pre-row of I, J, and info grid. Okay, I think. But instead of going forward from 0 to n, I'm going to go backward from n because I want to. Wait. No. Ignore that.
Okay.
And for a prefix column,
So you're basically saying this. Okay, but this is.
that might be
Would
out
this
of
be out of bounds? Yeah.
bound. Yeah. No.
I see. Okay. And basically you're storing like at index I, it's the total up to not including I, is that correct? For your row, it looks like. Because you're basically saying like for this row, for
yes,
column
I
plus
would do.
one, it's yeah.
Yes,
Okay,
I
got
would
it.
do a one index
Got it.
for yeah.
Okay.
That is for the pre-row.
Mhm.
Let me see. Now for the pre-column, we can do the same loop, but with a little twist.
Mhm.
Pre-column of j, I plus 1 is equal to the same thing. Yep. Still think there's a little bug right in this line. But yeah, I can come back to it later.
Okay.
So after having the pre-row and pre-column, we are traversing over. So I think I will use one base index
Okay.
from now on. So I can go over all of the grid. And then choose this point as a turning point for the problem. And then I will have another result.
Okay.
So at this point, I will do taking, I will have 4 cases. I think there's cleaner implementation, but I think I will code it out and see if I can clarify, shorten it later.
Okay.
So I would do this one as looking, starting from start left,
Mhm.
turn downward.
Okay.
So starting left is going to be prefix row of I, J. I'm going to merge with pre-com. Maybe we can do turning upward first. So pre-column of IJ. So what I'm trying to do is having this 1 and then to the left and then to up. So it's 8, 1, and 20.
Mhm.
But I do have the number 1 counting extra. So I will have another function called subtract.
Oh, I see. Because your thing in the middle, you're double counting.
Yes.
I see. Sure.
Did I have to clarify that better or?
No. Makes sense.
Then going to subtract from this merge to info grid of I minus 1, j minus 1, because I'm doing one base indexing.
Mm-hmm.
So going to be result is equal to max of result and result now of 0, result now of 1, but not really. We are going to take the min of 2 and 5. And this
So result now 0 is, hold
number
on.
of 2.
Result now you're doing merge. Okay, so are you getting 2s and 5s here, or like
Oh,
what is it?
okay,
What
I
is this?
can.
What does the result now have? Does it have 2s and 5s, or does it have the min?
It has 2 and 5. The number of 2 and 5
I
in
see.
the
I see. So you're taking the min of those. Okay, makes sense.
yes,
Okay, got
yes,
it.
and we can do the same for the other cases.
Mhm.
Let me do start left,
Mhm.
turn downward.
Mhm.
This is kind of messy. I don't like this line. So I will so start left and I will turn downward. Number 1, I will start left, meaning this one, and I will turn downward with this, with 1 and 10. So I will do prefix column
Mhm.
of j, then minus, yes, okay, I got it. Merge prefix. So we'll get the get column first.
So the sum of the column, like if you go back to this picture, if you go left and then, or still there? Okay, you dropped again.
Yeah,
Okay,
it
let me add you one more time.
keep
Okay,
about
here.
that.
Okay. So if you, okay, let me know when you join. Okay. So if you go
Yeah.
left and then you go down, like you're you want this total, right? This like 110. But if
Yes.
you do prefix column, doesn't prefix column start at the top?
Yeah, prefix yeah, I am changing that line right now.
Okay, I see.
So pre-column of j. Did I messed up on here? I think I did. I think this is j and I. Yeah, this is j and
Oh, I
I.
see.
Yes. So pre-column of j dot back. No. Yes, dot back. Minus pre-column of j I minus 1.
What does dot back do?
Oh, that back is the last element of a vector.
Okay, I see.
So this one will look at the number 10
Uh-huh.
as the back. Yeah.
Okay. But what if it's like longer? Why are you doing subtract the back? Like what if this was like 5 elements and you need to go down? Wouldn't you want like the bottom 5?
Yeah, I want the bottom 5 from this ij.
Oh, I see. Okay.
Yeah. Where was I? Yes, instead of this subtract, instead of this minus, I write this minus to just to make this better. So I would do subtract. Sorry. Yeah. So this will get the column.
Okay.
Now we get the row results. It's still going to be the same as before, so it's going to be pre-row of ij.
Mm-hmm.
And then we are going to merge both of them together.
Mm-hmm.
And then we do the same, take the min of
Okay.
them. But have not subtracted out. So in this case, I can do instead of doing another subtract to like the double count, I can do that as well.
Okay.
Yes. So did you follow that? Or
Yeah, you're basically saying like, what? Actually, you're saying you don't need to double subtract because your column doesn't include it.
yeah.
Okay. Yeah.
So, yeah. So instead
Okay.
of taking the bottom 5 like before, I take only the bottom 4.
Yeah, that makes sense. Okay.
Yeah.
Sounds good. Yeah, it's definitely hard to follow exact, like hard to double check this thing because it does get confusing. So it's
yes. So now we can do start right and turn upward.
Mhm.
So we start right, we will do a column, turn upward. So we will just have a pre-column of ji.
Mhm.
Now for the row result, we are going to merge. So start from the right. So it's going to be subtract from pre-row of I dot back and pre-row of ij.
Mhm.
Yeah, so basically the same as we do before.
Okay. And you're not double counting. You're basically just including the not.
Yes.
Yeah.
Yes.
Makes sense.
In the last case, is start right and we turn downward.
Mhm.
Let me do row result first because it's the same thing.
Mhm.
And for column result, I can just copy from here.
Yeah. Okay.
And instead of one of them, I will do -1 to include that in there.
Okay.
Okay. And we can just return result. But I have an account for the 2 case of like a straight line of row and column.
Mhm.
So I can do right here.
Okay.
Yeah, I can do this for the 2 cases.
Yeah, makes sense.
Yeah.
I think this is good. Okay, I think let's. I mean, it's kind of annoying to test run this, and like I think I get what you're doing here, and
Yeah.
like it's fine. So let's move on to the second problem. Okay, so in the second problem, you're given an integer n, which is the number of houses in a village, and then every single house will have a well. So, yeah. So every single house will have a well.
Okay.
And let me check one thing real quick. And okay, so let's also say that yeah, okay, so that makes sense. So every single house will have a well, which is just like an array, right? So that's just like array, and this is what was zero indexed. So this is the basically array int, and this is the cost to get water to the house. Okay, so basically, if you connect it to a well, this is the cost and water we get in the house. Okay, and you have another thing called pipes, which is edges that you can build. So you can think of it as like roads or whatever you want from one house to another house, and they
Okay.
are what's called bidirectional. So they're the format of x, y, and cost.
Okay.
And basically, what I want to do is provide water to every house. Okay. So, and I want to do this with the minimum amount of cost possible. So I need to, at the bare minimum, have one well. I can't just connect all the houses with no water. But
Okay.
from there, any house with water that's connected to a house without will have water in the house. So I basically want you to figure out like what's the optimal. I don't need you to figure out like what's the optimal way to use the pipes. I want you to figure out like what's just the min cost I can have to get the job done. So let me give you an example. Okay, so let's say we have wells 1, 2, 2. So basically the cost for house 0 will be 1, and then 2 and 2. And the pipes, so let's say house 0 is connected to house 1, and the cost there is 1. And house 1 is connected to house 2, and the cost there is 1. So the optimal is basically 3, because you can just make a well at house 0. So answer 3, because you can make a well at house 0, and then house 0 is connected to house 1, and house 1 is connected to house 2, and that would be the cheapest. Does that make sense?
I kind of not follow. So basically, I have n as the number of house in the village, and well is another given input.
Yes. So wells is also an array, and
Okay.
it's the cost to provide water to each of these houses. So you can essentially like think, okay, in my house I can get water in one of two ways. I can either have a pipe to a
Okay.
house that
Oh,
has
okay.
water, or I can build a well directly.
I see. I see.
Yes.
Okay. So basically, I am given a graph, a bidirectional graph,
Uh-huh.
not necessarily connected.
Mm-hmm.
Um, to provide water. So, do I have like a starting house where initially have the water?
So you can have water in any house by building a well.
Oh,
So
okay,
you can
okay,
pick, and you can have as many wells as you want. So the optimal solution might be just build a well in every house.
okay. I see. I see. So, can I know the constraint on how large n is and how many pipes?
Yeah, so you can assume that your answer, basically the number of pipes you can assume, or like, I guess let's do it this way. The result you're going to return will fit in an int. How about that? So I'm not going to give you like 10 to the fifth or whatever. I don't think that's
Okay,
relevant. But
okay,
the result you return can fit in it.
okay. So when I think, when I see problem of minimum, I tend to think of a Dijkstra algorithm in the graph.
Okay.
And yeah, so let me think of it.
Mhm.
Um, so we will use a priority queue, and we initially will push in all the cost from the wells
Okay.
as the maximum, no, the minimum cost to now. And in that, we are going to processes each house, and we will use the bidirectional edges of cost. And yeah, we can do the Dijkstra based on that. And the first time we reach a node in the priority queue is the minimum cost for that house.
Okay. So you're basically saying you're going to use Dijkstra's. You're going to put in every single well into the Dijkstra's, and
Yes.
then it's okay. And then let's say once you take a house out, then you will
Mm.
put like other houses in based on cost and
Yes.
near them or something.
Yes.
And it will
So
be okay. I see. Yeah, keep going.
yes. So what am I supposed to return for every house, the minimum cost to make it?
So I want you to provide the total min. So is it always that? Can you tell me if the minimum cost to get to a house will always be the minimal answer to combine it all? Because essentially, if you think about it, like I have a graph and I want to connect all the nodes in the graph.
Yes.
So by doing that, is it always optimal to just take the minimum distance to reach every node from where I started or whatever, and will that give me the best answer?
Mm, so in this case, I can think of. So you want the. Let me ask the question again. So you
Mhm.
want the minimum cost to provide.
So I want the minimum cost to provide water to every house, not
Okay.
to each house. So
Okay.
if I
Okay.
get the minimum for each house, will that give me every house, like total?
Yes. Okay. Um.
Which I'm not sure.
So the Dijkstra. Um. mm,
Because I have a feeling that if you pick one house, even though it's cheaper, it might make the whole thing worse.
Yes, I do. I do see that problem. The minimum cost of a well. I would think about this in a bit, and
Mhm.
we want to connect this so we can do. There's another algorithm I think of, which is Criscal
Mhm.
for minimum spanning tree.
Mhm.
In this case, we can use DSU to combine. Yes, but it. Huh. This is interesting. Um,
Yeah. So do you know? I guess yeah. There's two algorithms to do minimum spanning tree. I'm guessing you know them both.
yes.
Okay. So what's the problem with minimum spanning tree that like so I do agree that approach will work, but what do you need to have a minimum spanning tree? Like why is this one maybe difficult to do?
Because we have a pipes
Uh-huh.
for each house, which is not an edge.
Yes. Well, it is an edge, but
Yeah, an edge
but
like
it's
a
not
self
complete,
edge.
right?
Yes, yes.
Yes. So is there anything you can do to make this compatible with the minimum spanning tree? Like if you think about it.
Yes. Have X, Y cost, pipes, wells, that's the array int and cost to get water from the house. Okay, so I can imagine we have a graph with all node with the initial cost, and we have edges to connect them. each with cost separate.
Mm-hmm. Like basically, if every X and Y had pipes,
Yes.
and there were no wells, then you could do it, right?
Yes.
But
Yes.
right now, pipes aren't everywhere, but wells are everywhere. So can
Yeah.
you combine them to make a valid graph in a way?
Um. Hmm. I think we can still sort. I think we can.
So if you sort, you would sort like by cost or something.
Yes, I'm thinking about sorting both the wells
Uh-huh.
and the pipes together in a like a general vector.
Mm-hmm.
Um. Yeah. So when we connect to node from DSU,
Mm-hmm.
there potentially will be. How do I phrase this? So that edge is the minimum at that point to connect these two, or another. Yeah. So we can use that edge. Another option is we have a node on only from the wells.
Mm-hmm.
Which is it worth it to connect? Mm, yeah, the wells is annoying component in this problem.
Right. So I guess if the wells were a node,
Yes,
then how would this be done?
if the wells is the node.
Yeah, because you know you need to connect at least one house to the well,
Yes,
right?
yeah, that's
So
correct.
so how would this be done then?
So basically in a component of DSU, when we connect all the edges,
Mm-hmm.
I think only one node with the minimum. Wait, is that correct? Oh yeah, okay. I see now. So we will take the minimum cost of the wells and then pipes. We just cross count the connected graph and then plus the minimum from the wells. To, basically, I start from the minimum cost
Mm-hmm.
house, and then I connect to every other house using the edges on the pipes
Okay, but
using
what if I
DSU.
don't have enough pipes?
Okay, so
Like I
in
have
that
like
case,
20 houses and 2 pipes or something.
yes, in that case, we can take the minimum from each DSU component. Each minimum node in the each DSU component.
Okay. So what do you mean like each DSU component? Like if I have like 2 pipes, like so what would the components be, I guess?
Yeah, so I have A, B, C, for example, and another
Mm-hmm.
D, E. I would take the minimum from this. For example, it's going to be wells of A.
Mm-hmm.
Then this one, I would take wells B.
Mm-hmm.
Oh, no. D, I meant. Assume that A is the minimum cost and D is the minimum in this component. And then I will plus all of them.
Well, so okay, so I see. So you're basically saying like this is that, it's that.
Yes.
Okay.
The pipes connection is the general cost. And then for each component, we will take the separate cost.
Okay, I see. Okay. So what would be the time complexity for this?
Yes, the time complexity is O of n times the Ackermann of DSU,
Mm-hmm.
which is pretty fast with the path compression.
So for Crucial, don't you have to sort?
Yes, so it's going to be n log n for the sorting,
Okay.
and the connection of the DSU is n times the Ackermann.
Okay. Okay. Yeah, that sounds good. Do you want to code that?
Yes.
Okay.
Okay. Let's trying to use the Vim mode, but it's... So we will have initial n.
Mm-hmm.
A wells, and another one is a pipes. Will be 3. Can we have, we have this right here. Okay. So if n is 0, I'm going to return 0.
Mm-hmm.
So first of all, we are going to sort the pipes.
Okay.
The pipes is going to be XY cost. Is that correct?
Mm-hmm.
So we return.
Okay.
Okay. We are going to create a another DSU
Mm-hmm.
class. This we have a DSU, we have the find and the merge. So we will write a find first.
Mm-hmm.
If root of x go to -1, return x. Okay. What happens? Okay, sorry about that.
Sure.
They are in the same component,
Mm-hmm.
so not merge. So if they are in the different components, we are going to return true, and then root of parent v is equal to root parent u.
Okay.
Then for faster compression, we can okay. But we do have another one to track is the minimum cost.
Mm-hmm.
So we will have another vector of minimum min cost. And then we will pass in the wells to the constructor.
Mm-hmm.
Then min cost is equal to wells. Yeah, that's for the DSU. And now we can create a DSU, call it root and n and wells. Now we begin to merge for the pipes. We have so it does fit in int. Is that
Mm-hmm.
correct?
Yeah.
So I'm going to say if they are mergeable. If they are mergeable, meaning they are in the different components, I am going to plus. This is like base merge cost.
Okay.
Then in this merge function, we haven't done the take the minimum from each one. So I'm going to do basically to track the minimum wells from each component.
Mm-hmm.
Yes, and then we will have another one of min cost total, which I will take from each component, the minimum cost. Now I'm going to go over all of the node, see which one is the root. I'm going to plus equal to and then I will return the base merge cost plus min total. I think that looks
So just to confirm what you're doing here, so you have a root, right, which is like your
yes,
DSU. So you try to merge, and if you do, then you add up the cost of this pipe, right?
yes,
Okay. Then you go through all of these and you get the root, and you add the min cost. So you're basically adding the min cost for every group. Is that
yes,
correct? I see.
yes,
Okay. Okay, I see. Okay, got it. Okay, so and then the basement. So this is like the pipe cost, and this is like the well cost.
yes.
Okay. So I think the thing. I think we're like we're on time, so we could stop. But the thing basically I was hinting at, which I don't know if your solution will work because basically, so if I have a well, right, we can call that W. So I have this like X to W cost,
Okay.
and this is some cost, right? And then I also have my pipes.
Mhm.
So because every node is connected to a well, if you sort, sometimes the well will just be better than a pipe and you'll never use the pipe. Does that make sense?
Yeah, that does make sense.
So that's why I wasn't like I didn't want to just like tell you the answer, but I was like, I'm pretty sure this wouldn't
So,
work because you're always using pipes and you shouldn't be.
oh, okay,
Yeah. And yeah, I was like, I don't want to tell you the exact same I don't want to tell you like the exact algorithm, but yeah. Okay. But I think we still have enough to do feedback.
okay.
So
I see, I see. So it's the counter case on that.
yeah, exactly. Because yeah, basically imagine all your well cost is 1 and all your pipe cost is like 50 or whatever.
Yes,
You would
yes,
just
I
use
do
wells
see.
only. So I was basically hinting just like make wells a node and then it could be part of your DSU. You know, you take n and you just do like +1 or whatever.
Mm, that makes sense.
Okay. So I
I
think
did
oh,
not
yeah.
see about like I just in my head I just think about connections.
Uh-huh.
And I just completely forgot that I can just like use the wells on one node and call it a
Yeah.
day.
For what it's worth, I think actually that Dijkstra thing you said in the beginning might actually have worked. And maybe I was wrong there, where you just said take all the wells and put them into Dijkstras, and then just like, and then anytime you get to a node, then add the pipes. I think that would probably work because that would essentially give you like all the possible edges, and I think that would work.
Yes.
Yeah. Okay. So okay. So I think for the first one you did quite well. You came up with everything very quickly, and you came up with like the time and space, and you came up with backtracking prefix sums. Like I was basically expecting you would know like all the time complexity of like everything, pretty easily,
Yes.
and you did. And then you talked through what you were writing. I think the only thing is, and this is what I see with like everyone that does, code courses or whatever, just try to use better like try to make your code cleaner. Like easy stuff is like don't use standard vector, import vector. It's just less, more readable. Try to have variable names that aren't one letter, like ij, uvx, whatever. Like
Okay.
try to have it more readable. I think these are like very easy things you can add. And then yeah, so I think that's and then you're very good at making helpers like all over the place. You were like, oh, I need this. Oh, I'll make this quick helper, and then I'll use it everywhere, which is really good.
Okay.
Uh, you could have simplified the thing that you had. Actually, where did the first one go? Did you delete it? I guess.
Yeah, I think
Okay,
I
it's fine. So yeah, so for the first one, you were like, okay, I have these like 6 cases. How can I make them clean? So one thing you could have done was you could have calculated the left, up, right, down, and then you could have just like had 2 for loops, right? So you could just do like
Mm.
left plus right, left plus up, whatever. As long as they're not the same, then just like you can basically store the results in an array and you just like double loop, and then that would have been cleaner.
Yes,
Um,
I see.
but it was fine, and it was kind of hard to know the exact like where do I start, where do I end. So I feel like it was hard to follow. It was like that's just the problem that's kind of annoying. So if you're like off by one somewhere, I don't really care. Like
Mm.
it's already confusing enough as it is, and you figured out everything very, very quickly. So I think that was really good. I think you're able to, yeah, basically write modular code. Maybe a thing that you could have done that's a little bit better is instead of writing lambdas everywhere, maybe you have separate functions and then call them just so it's like more readable. Once again, like
Okay.
it's not a leak code contest, so like readability matters a lot. And
Mhm.
I think for someone who is like very high leak code rating and stuff, it's very easy for you to read your code that's super long and has
Mhm.
like, the variable names you're used to, but the interviewer, it's going to be tougher. So you can
Yeah.
assume like the interviewer is going to be worse at this than you are by a decent amount.
Okay.
So I
So,
would just try to
you
make it
would
as simple as you
suggest
can
like
for them.
make an like just a separate function
Yeah,
instead of
exactly.
lambda? Okay,
Yeah,
I see.
yeah. It just like readability, because
Yeah,
like
yeah, I
I,
see.
I can clearly tell that like I or like 99.9% of people are going to be worse than you at like algorithms, right? So it was like a little bit hard for me to follow some parts you were doing because, and for most people, they just don't come up with anything complicated, and I never ask them this stuff, and it's no problem. But your interviewer is probably going to be like, it's even going to have a harder time than me because the average person doing interviews isn't like 2200, 2400 leak code rating, or whatever.
Yeah,
So you want to make things like as readable as you possibly can,
I
separate
see.
stuff out, have clean variable names. I think you talked about things you were doing pretty well. Like I could follow it pretty well, but definitely there is and I don't know if this is good or bad. Like it might just be a good signal, but I've had a lot of people that were like very strong algorithmically being like, so there was probably a simple solution, but I figured out how to do it with like some crazy, like, lazy segment tree or something because
Okay.
I couldn't be bothered figuring out the simple solution because
Yeah.
your toolkit is like 10 times bigger than most people. So definitely try to figure out if there's like a simpler solution and don't go for like something more complicated. I think the second one was a good example of that. Like basically if you realize like a well is a node, then it's like a very simple solution, right? Like you
Okay.
can just, yeah. Um
So like I can ask you like so like if I see the problem is like direct extra, do I have to talk about a brute force and like explain my
no,
thought
no, no,
process?
no. I think
Because like
like
the first one I did
yeah.
like explain that in the way like backtracking, but I
Yeah.
can like say the exact solution at the
Yeah, no, I thought it was good. I thought it was good.
okay.
Honestly, for the second one, the solution you came up with wasn't super complicated. I'm just letting you know, I guess, of like a thing that people aren't into and like
Mm,
don't like basically you're at a point where like your algorithmic problem solving and all that stuff is like exceptionally good. And the only way you can screw up is like you misread the problem, it's hard to follow your solution, like all these simple things, right? So I'm just
okay.
trying to point out like all the really simple things you could do to make your life easier and to make it so likely that like the interviewer doesn't like mark you down or whatever.
Okay.
And then yeah, so you had some small bugs, but they weren't too big. In your factorize function, you had like if x mod whatever is 0, do something. You never decremented x. Once again, the problem is
Oh,
kind of big.
okay.
It's like not the worst. But definitely for a simpler problem, like realistically, you're not going to get asked this kind of stuff. It's going to be simpler. So make
Okay.
sure that like your code is correct. Depending on your interviewer, like they might care about that a lot.
Okay.
So make sure it's correct as possible.
Mm,
And then let's see. Yeah, so for the first problem, basically gave you like a 5 out of 5 for DSA, 4 out of 5 for coding, 5 out of 5 for communication. Your speed could have been improved, but you were also like lagging out of the call like every 5 minutes, so that probably doesn't
yeah.
help.
Yeah,
And I
because I
mean,
have like the
yeah,
control W as like remove in the Vim motion.
yeah, yeah, definitely don't do that in the real life interview. Um, I mean, yeah, you can like you basically never get stuff thinking. Whenever you think of something, you come up with an instant solution. Like I expected that. You're like, oh, I need a helper here. I need this to here. You like never get blocked. So yeah, I think overall you do quite well. And then for the
Okay.
second one, so yeah, so you said it was a graph. Like honestly, thinking about it again, I do think Dijkstra's with what you said would have worked. In a real interview, this interviewer would have asked the problem like 20 times and they would know with uttermost certainty if it would work or not. For me, I
Mhm.
haven't asked this problem or done this problem in like 2 years. So I'm just
Okay.
kind of like thinking about like, does it make sense to me? And I was like, not sure. But thinking about it, like, does the min cost getting everywhere? Like, how can it be bad to get somewhere in a longer amount of time, that doesn't make any
Mhm.
sense, right? So like, so the greedy just like take the best all the time should add up to the min MST, because I mean that's how Dijkstra's MST works anyway. Like I think you
Mhm.
did Kruskal, the other one was what, like Prims or something,
Yeah.
and that one is basically just greedy, take the shortest path at every node, right? So I
Mhm.
think what you said would have worked. So it's probably on me that like I screwed you up a little
Yeah.
bit.
Yeah, so, like, when you mentioned the problem, like, I straight up think Dijkstra
Uh-huh.
on that. Like,
Yeah, for sure.
yeah, but when you say it's wrong, so
Yeah,
what I would
yeah,
do in contest is, like, code that thing up and
for
then,
sure. Yeah, yeah. In a
yeah.
contest, you can code it up, and so that's what I'm saying. I think that's on me. That I think it would have been right, but you should also be able to code the other one. And
Mhm.
I think the other one was wrong, right? So like,
Okay, yeah.
so if you like, yeah, the other one was definitely wrong, and I think we
Mhm.
proved that. I think the first one
Yeah.
would have been right. So like I said, that's on me for like in a real interview. Like the problem with this kind of stuff for me is I can't ask this question to everyone because then people watch this stuff and then they know what I ask, right? In a
Okay.
real interview, I can just have one question and ask it and be like super good with it. So sometimes I
Mhm.
get into spots where like because your solutions are pretty complicated, or I don't know, maybe, or at least harder for me to follow than most people. Like sometimes you'll say something that's right, and I'll think it's wrong because I just haven't done this problem like 50 times.
Okay.
So, but yeah, I think it was fine. But yeah, I do think like obviously for the other one, you do want to be correct. So honestly, if I had asked this problem like 50 times and you said Dijkstra's, it would have been fine.
Okay.
So I do think yeah, like that part is fine. So I think the main takeaways here is yeah, whenever you make helpers, probably don't make lambdas because if you have some like 50 line, 70 line function with 20 lambdas, like it's going to get complicated. Try to
Yeah.
separate out your code, try to make your variables readable, try to basically don't miss anything. Like
Mhm.
for that second one, even though the first solution was right, the other way was definitely wrong. So I think you want to think about it in the way of like, I know I have the skills to pass by far. What are all the stupid things that could screw up in? So that's like
Mhm.
make sure you understand the problem. Make sure you know the constraints. Make
So,
sure.
like,
Or yeah, go ahead.
can I ask, so, like, the second solution I was wrong, but, like, for you as the interviewer, do you correct the candidate right there?
So I can
Or
go one of two ways. So realistically, so here's what happened actually. So the second solution you made, I wasn't super sure what you were doing,
okay, I see.
and until you started coding, like it wasn't 100% clear in my head. And I could have been like clarify it more, and people could do that, or they could just be like, yeah, whatever, code, and I'll figure it out.
Yeah.
So I was like, I'll figure it out. And then once you started coding, I'm like, oh, I see. This is what's going on. Okay, this is definitely wrong. Like I wanted to be super sure that you were wrong because I mean maybe like intimidation or something. Like I know you're a lot better at Leetcode than me, so I don't want to say you're wrong until I'm super certain,
Yeah,
right?
I'm wrong a lot. So
Yeah. So so that's basically why I said it there. Like I wasn't sure, and then once I saw
okay.
your code, I was like, okay, it's definitely wrong, and I'm like 100% sure now.
So, like, in the actual interview, does it meant to be a fail if that
So
happens?
in the actual interview, you can go one of multiple ways, right?
Okay.
Worst case, they just let you do whatever you want and you fail.
Mhm.
Best case, they understand what you're doing and they pivot you in a direction, but they can also understand what you're doing and let you keep going and fail. Like I've seen that happen too,
Okay.
you know? So it
Mhm.
is good to clarify what you're doing, but it is also good to make it as easy as you can make it because you are one of those types of people that can make a really complicated solution and your interviewer won't get it and they'll be like and they probably won't be like I don't understand it, can you explain it 5 times, you know? And so
Okay.
they'll just be like all right, keep going, whatever, I'll figure it out. And then and then maybe you run your code and it doesn't work or something.
I see.
So like I
Yeah.
said, I think the second one was partially my fault, but also you should recognize the other thing. So
Mhm.
it's kind of like a
Yeah.
50-50 type of thing.
Okay.
Okay.
Sounds good.
So I think as long as you like clarify the constraints and like have solutions that are pretty simple and like yeah, basically split your code up and stuff and like make things readable, like try just think of like the interviewer is way dumber than me. How can I make their life easier? I guess. Like
Okay.
I think that should be basically your goal. And I've had
Okay.
some, I don't know if it was you or some other guy also was like some like 2700 leak code guy and he's like most interviewers are like stupid or whatever. It's like yeah, if you're like at this level, most interviewers are like significantly worse at this stuff than you are and you want to make it as easy as you can for them.
I see.
Yeah. Um but yeah, I think overall I think yeah, basically your problem solving is like super great, like I said, and then you would, yeah, you would. I think you would do very well. The only issue you could have, judging from my own experience, the only like if you're way better than me, and the only time I fail this stuff is like when I misread the problem or something stupid. It's basically going to
Mhm.
be the same thing for you, you know. So
Okay.
so yeah. Yeah. So do you have any questions?
Yeah, that sounds good. Yeah, I think I will do some more with you in the future, just
Okay.
to practice talking more.
Yeah, I'll definitely try to prep some stuff ahead of time because I didn't
Mhm.
know like where you were at. So I think for people that are very, very good, I think I want to prep ahead of time and really know all the solutions before before just asking you random stuff and kind of knowing it. Because I think with these kind of interviews, there's a lot more room for me to trip up because
Mhm.
it's just more complicated and it's like it's hard to do on the fly. Where for
Okay.
most of these, I can just think of it and like it's fine and it takes 2 minutes and whatever. So I definitely will. We'll just probably take like 20 minutes to prepare some stuff next time.
Okay.
Okay, cool. Well, sounds good. Yeah, feel free to book more in the future.
Okay. Thank you so much.
Cool. See ya.
All right, see you.